Okay, for 7.3 day 2, we are going to get to the product and sum formulas, but the first part is going to be continuing. Guys, can we be quiet? The first part we're going to continue with what we did yesterday. So we're going to evaluate the cosine of theta over 2, which is a half angle, and you're given the tangent of -3/4 with theta in quadrant 4. Okay, so we're going to draw theta in quadrant 4. And then remember, we know that the 3 is negative because this is below the x-axis here. So anytime you are in the 4th quadrant, your x is going to be positive, your y is going to be negative. And you can always use your all students take classes to remember what the signs are. But in the first one, x and y are both positive. In the second quadrant, x is negative, y is positive. In the third, they're both negative. In the fourth, x is positive, y is negative. Okay, so that's why I have to make sure my 3 is negative. And then you can solve using the Pythagorean theorem for C. This is also a Pythagorean triple, the 3, 4, 5 triangle, so you could also do that from there. Now, if I'm going to find the cosine of the half angle, if you look at your formula, the only thing that you have to know in order to do the half angle of cosine of theta over 2 is the cosine of theta. Okay, so even if you find the sine and the tangent for this one specifically, because we're only finding one of those, all we need to know is going to be the cosine, okay, the cosine of u. So the cosine of u is 4/5. And we are going to substitute that into our equation. Okay, so here's our equation for the half angle. U over 2 equals plus or minus the square root of 1 plus the cosine of u over 2. Now, we have to decide if this is going to be a positive or a negative. And so let's talk about how we're going to do that. So what we're given is that theta is in quadrant 4. So if we think of the degrees on quadrant 4, would you guys agree that in quadrant 4, I start at 270 degrees and it goes to 360 degrees for quadrant 4? Okay, so theta has to be somewhere in that interval. Okay, so to figure out what the sine is, we know theta's in quadrant 4, which means it has to be between 270 and 360, but we're trying to find theta over 2. So if I take the 270 and the 360, and I want to find theta over 2, I can just divide all of these by 2. So if I cut 270 in half, okay, half of 200 is 100, half of 70 is 35. Half of 360 is what? That was weak. Half of 360 is what? 180. So if I'm looking at 135 to 180, okay, Anuva, what quadrant goes from 135 to 180? What quadrant contains those? 2. Quadrant 2. Okay, so what we have to do is follow the rules for quadrant 2. Since we're dealing with the cosine, we can just look at the cosine value. And in quadrant 2, the only thing that's positive is sine, so the cosine is going to be negative, which means I'm going to put a negative in front of my radical here. Okay, so you can take your theta with what's given, you can divide by 2, and then go ahead and find what quadrant this is going to be in. It's in quadrant 2, and then we're going to follow the signs for that quadrant. Now, when you're plugging this in, this is cosine of u. We know that cosine of u is going to be 4/5. So we're not plugging anything in for u. That's what we did yesterday. Today we're plugging in the cosine of u. So we're plugging in that whole thing. Okay, and now what you have to do is simplify in order to get your final answer. So if I'm going to simplify, I want to add these together. 1 plus 4/5. Okay, so I'm going to get a common denominator, 5 over 5. 5 plus 4 is 9, so 9/5 over 2. And then I'm going to, instead of dividing by 2, I'm going to multiply by the reciprocal. I'm going to multiply straight across. When I multiply, 9 times 1 is 9, 5 times 2 is 10. I can take the square root of each. The square root of 9 is going to simplify to 3. Square root of 10 is going to stay the same, but I can't have a radical on the bottom, so I need to rationalize. And then this will be my final answer.